Welcome back to another episode of How and Why with DTI. I'm your host Mike Renner, and today I've got Ed Fitzgerald with me again. Ed, today we're talking about air monitoring selection guide. You know, when we talk about air monitors, let's talk about really why do we need an air monitor? What's it for? What's its usage? What's the main reason to have an air monitor?
Well, the obvious reason is health and safety of your operator.
100%.
The not so obvious reason is OSHA requires it.
Yeah.
And people look at the OSHA requirements at time and go, oh, holy smokes, who in the big white ivy tower came up with this one? Let you in on a little secret. OSHA doesn't write standards until a whole lot of people that are injured, maimed, to die first. In the case of the confined space activities where we use most of our air monitoring at, in the early 90s when this law came out for confined space entry and required air monitoring, OSHA realized we were losing some 1,500 to 1,800 employees a year across the country in confined space related activities. Today, after these standards have been invoked and we're following them, that number's between 80 and 100. The number's still too high, I agree. But the point still remains is 80 to 100 is better than 1,500 to 1,800. That 80 to 100 are those people that still aren't following the standards. So the air monitor itself as a requirement is, as most of us know, gases like low oxygen, methane gas, carbon monoxide, no smell, no odor. Can't tell, can't see, smell, taste, or touch it. The only way you're going to see that is to put portable gas monitor, sniffer, gas detector, it's called a few different things out there, into the application to see if that atmosphere is correct in the right breathing atmosphere.
Yeah. I mean, you know, you talk about that and you talk about those atmospheres, but, you know, how do you lose oxygen in a confined space, Ed? What causes that? A little bit of details behind that.
Well, oxygen leaves an atmosphere displaced, absorbed, breathed up. Curing concrete can absorb oxygen in the curing process. Most people don't understand it's 5 to 7 years to fully cure concrete.
Yeah.
We talk about it's 27, 28 days to full hardness, but full cure is 5 to 7 years, and it'll absorb oxygen during that process. And the space is closed up. You take a meter vault and we close it up. There's no way to replace that atmosphere without ventilation, so you need to check it. We talk about gases like methane and hydrogen sulfide. They're generated through natural decomposition of organic material. Things like compost piles and the organic material we find in storm and sanitary sewers like rotting leaves and grass will create both methane and hydrogen sulfide. Methane gas, kind of misunderstood sometimes. I think everybody that is watching this video has been exposed to methane gas. You call it natural gas. You cook your bacon and eggs with it at home. The natural gas you have coming into your home, about 85% of that is natural, is methane. The other 15 or approximate 15% of that is the odor, the percaptant that's put in there. So we can smell it leaking because methane has no odor. Hydrogen sulfide obviously has odor. It's toxic, it's flammable, but it'll numb the senses so fast you won't know it's there after a short period of time. So again, these are some things that we look for, and they're naturally occurring in the spaces that we get into, things we need to look for.
Yeah, I mean, that's a good explanation. Is, you know, you hear the term gas monitors, and you and I have seen it. Guys will jump in a manhole without even thinking about it before jumping that in there. And safety-wise, you know, it doesn't take but a couple seconds to put a monitor down there to test it out, a couple minutes at most. But the safety factor is exponential from doing that. So that's kind of what we're looking at here. You know, when we talk about air monitors and selecting the right air monitors, the first thing you need to know is what gases need to be detected for your application. And I think that's the key that a lot of people forget is, you know, I just need an air monitor for this, but really you got to know what application you're getting into. You know, we do a lot with guys who jump into manholes or confined spaces and in that type of environment. And so we know that extremely well. They seem to know it. But there's other things you can do. Chemical tank cleaning is one, Ed. Talk about the gases that you want, what gases you want to look for. What are your kind of standard across the board gases, but then what are some of the ones you might want to look for depending on applications?
Well, oxygen, a separate reading for oxygen, separate reading for flammable, most commonly called LEL, lower explosive limit. Those are standard. Those are going to be in all your air monitors. Those are givens. When it comes to the toxic gas, Mike, hydrogen sulfide and carbon monoxide are by far the two most common toxic gas sensors put in portable air monitoring today. Why? Because the application of municipal and industrial waste treatment is the biggest user in these air monitors, and those are the two that they select. We get into other industries, chemical tank cleaning, fuel industry. We get into other industries where the toxic gases are more than or not at all hydrogen sulfide and carbon monoxide, although very common. There's a number of different toxic sensors available for the portable air monitor today. Some of the monitors this particular one has 4 sensors in it: oxygen, combustible, carbon monoxide, and hydrogen sulfide. Although you can get air monitors with up to 6 sensors in them, 4 of them being toxic sensors for different background toxic gases. So in review of your space, which should be done before you enter, what hazards will be confronted when entered into that space? Do that evaluation, you can tell what sensors you're going to need for your particular instrument.
Perfect. I mean, that's the number one thing we're looking is knowing your environment, knowing what kind of spaces you're getting into, and finding the make sure that the monitor detects the gases and the hazards you're looking for. You know, we talk about that's the number one, but really, in my opinion, number 2 is really how easy is this thing to operate. I mean, you don't want something that's clunky, and if you're passing around and multiple employees are going to use it and it's a long, steep learning curve, you want something that's pretty easy for guys to operate, jump in and go, so you know, 1, they can operate it, and 2, it's going to operate correctly and keep them safe. Talk a little bit more about that, Ed.
Well, ease of operation is a big thing. Most of us in the field doing this work are not analytical people. We don't run this instrumentation every day. You have a monitor sitting on the table right now and it's not making any noise. If it's a low oxygen or flammable atmosphere, it would go into alarm. Not beeping good, beeping bad. Yeah. Pretty simple. Monitor gets turned on, but the basic understanding of what is good and what is bad, we're going to get into that in another podcast. LELs and TWAs and O2 and CO and where the alarm points and the effects. We'll get into all that in another podcast. But basically turn the monitor on. You let it go through warm up. Through that warm up process, you can tell when it was calibrated last. We'll talk about calibration in a little bit here. This particular one has a peak hold function for data recall. When I sample with the air monitor, it's a requirement that you take a minimum of 3 samples in every space. Those samples could be no more than 4 feet apart, high, medium, and low. So the space is 20 feet deep, you're taking 5 samples. Again, no more than 4 feet apart. You need to recall the worst reading in the space. This particular one has a peak hold function and it locks all the readings on the screen. Yep. So it's really easy to get a hold of. Some air monitors require you to push a single or multiple buttons multiple times to get those readings. Understanding what you need to do to get the data recall, fill out your confined space permit is important. But again, you see in most air monitors, if you were to look at this with the lights off, the display screen is green. That's good. If it goes into alarm, the display screen will be red. That's bad. So even the person that doesn't have the environmental education, green good, red bad. Yeah. It's got light bars that light up. It's pretty straight up.
I mean, you look at it, you don't want something that you have to write code to work or something. You want it to be easy. Make sure you guys understand it. Make sure you guys have been trained on it and can go out there and run it efficiently. You mentioned calibration, Ed. One of the things you have to do on these air monitors for them to work properly is to calibrate them. Mm-hmm. So you want to make sure when you understand how easy is the calibration. Does it come with a calibration kit? There's multiple ways you can calibrate it. We have an example right here, Ed. Kind of walk them through the calibration and a little bit more about that.
Calibration is the process where you take a known concentration of gas, which is a certified bottle of gas. We know exactly what's in the bottle, what concentrations. We apply it to the instrument and make the air monitor, gas detector say what the bottle says. What you're seeing in today's industry is all the gases are in one bottle: oxygen, combustible, carbon dioxide, hydrogen sulfide. They all live in this bottle together. On the calibration cup, in this particular situation, you have 3 little spring-loaded pogo pins that when this cal cup is applied to the instrument and tightened up, those 3 pogo pins align with connectors on the monitor itself. The monitor goes into calibration mode, and it simply asks you, do you want a fresh air, zero the instrument, or calibrate it? And I push the cal gas, and then the next screen that comes up, it says, did you turn the gas on? You turn the gas on, push the yes button, and the monitor will do the rest of it itself. It's all built in. You're gonna see what some manufacturers require a docking station to do this, where you physically lower the instrument and close the box on. It does the same thing, rather than a simple calibration cup. We're still using a known concentration of gas, but we're putting the instrument into a fixture that will tell the monitor through electronic connection that the instrument's in a calibration mode. The question, you know what the question that comes up most frequently, Mike, is?
What's that?
What does OSHA say I have to do for calibration? OSHA says you have to follow the manufacturer's recommendation on calibration. OSHA doesn't give a time frame. Most manufacturers out there, 60, 80, 180 days, depending on the manufacturers. You get an operation manual with your air monitor, review it, take a look at it. Understand there is a difference between bump testing, which is the application of gas on the instrument to see if it can see the atmosphere, and calibration, which is adjusting the instrument to an exact known concentration of gas. The question comes up, I'm the operator, was the instrument calibrated? What you're seeing in today's industry with these microprocessor-based instruments is when you turn them on, it's going to come up and say next calibration due in this many days. It's going to come up and say last calibration was done on this date. You have to understand, operating the instrument, what does the manufacturer recommend for calibration? Those dates come up on the instrument, or a window of time comes up on the monitor and tell you it's been calibrated, it doesn't need to be calibrated. But to be really honest with you, calibration, and you look at the whole situation, if I have 4 or 5 air monitors, I only need one of these bottles. I don't need 4 or 5 of them, I need one. Calibrating the instrument by the end user, it's that simple. It's as simple as what I just did. Some people have a box or a cradle they fit in. Same basic idea.
But you want to understand the calibration of the device when looking at it. Make sure it's easy. Make sure what you need to do it. That's something you really have to take into consideration when selecting a monitor. I mean, the version we have here is what we just showed you, but there's other ones out there that may have a little bit different and may have. Just understand totally what you're getting yourself into and how to calibrate it, so that way you can make sure it's calibrated and working for you.
Hey, look, it's a Ford, it's a Chevy. I mean, they all do the same thing. They just operate a little differently. Don't hesitate to look at the calibration. Don't hesitate to go online, go to places like YouTube, and look that particular brand and model up, because most air monitors today, the manufacturer actually has video on operation and calibration and maintenance of those meters on YouTube.
Yeah.
And those of you out there that aren't really familiar with YouTube, ask your grandkids, they'll hook you up.
That's what Ed did.
That's how I did it. My 5-year-old granddaughter showed me how to use YouTube. Yeah.
So we talked about, understanding calibration, ease of operation. When you talked about the data that these things will store for you, and data logging and recall, that's an important thing you need to understand. What data does it keep in there? How do you recall it? How easy is it to recall it? Does it tell you when you need to be calibrated right off the bat, or do you have to go in a menu and look at that? Things like that is what data logging does it have, and how do you recall that? Ed, expound upon that a little bit.
Two pieces of data you just talked about. Let's talk about calibration data. Most monitors today, as we have here, when the instrument's in its warm-up cycle and it exceeds its calibration window, in the warm-up cycle, it comes up and tells you calibration's needed, and the meter locks up on that screen and forces you to manually advance past the screen. So you physically have to handle the instrument. It doesn't go through by itself. A lot of monitors do something very similar to that today. The other data recall that is important is the data you got when you lowered the air monitor into the space. To evaluate the space, you need that data to go on your confined space entry permit. So whether you have a peak hold function and lock it on the screen, or you push the button multiple times to see what the peak readings are, I haven't found an air monitor in the field yet today that doesn't have one or the other feature. Most of them you have to push the button multiple times and cycle through some peak readings. Again, we're going to talk about some of those readings in another podcast, but whether you have to push multiple buttons, you need to know where it's at.
Yeah.
And you need to be able to pull that information up. Or you have a simple button, you push it once, it goes into a peak hold and it stays there for you. And it just locks them in and gives me the ability to read it. So data, two forms. Calibration data, and again, the calibration data is not going to be necessary until I go to use the instrument and I want to make sure it's calibrated correctly. Or somebody got hurt, we want to make sure it's calibrated. So it's important. Today's monitoring equipment pretty much locks it in on the meter.
Yeah, it's very important, and how you get to that data and how easy it is, that's something you want to take in consideration when choosing an air monitor for your application. You know, one thing that I feel like a lot of people don't take into consideration when looking at this is what operating temp can these things work into. And you know, there's different environments, different things, and you know, if you're going to be in an environment with some pretty high temperatures, pretty low temperatures, you need to make sure the monitor you choose can operate in the range of temperatures you're going to be working in.
Yes, this is all part of the specification of the air monitor. You look at a monitor like this, plus 120 to minus 20 degrees Fahrenheit. Some of you are going out there looking at that going, I'll never see numbers like that.
Yeah.
My son lives in Phoenix, Arizona. He's going to see the top end, and we have customers that live in Alaska. They're going to see the bottom end, or less than the bottom end. I want you to keep something in mind. Make sure the monitor can run in the temperature range you're working in, and look at the actual temperature you're working in. If I'm working in a manhole, they tell me in engineering that underground is 50, 55 degrees thereabouts. That's a manhole. That number's going to fluctuate because the manhole cover's open and cold air's entering into it. But look at the application, not the temperature necessarily outside. Most confined spaces that in our industry that we get into are underground.
Yeah.
Manholes, vaults, that type. There's some above ground tanks. Again, look at the actual application and where the monitor, because that monitor could come from your vehicle and be put into the manhole and not really spend much time in that 5-degree temperature.
Yeah.
It's going to go from a 70-degree truck into a 50-degree manhole. That's okay.
Yeah.
So take a look at the real application, but temperature range is a huge thing that you need to take a look at. Again, in our industry, I don't move around very much because it's underground industry. It pretty much stays the same. But in other industry, it's a huge issue that we have to deal with.
And just look at that. I mean, when you're comparing what you're looking at and what you need, make sure you know your environment. You know what operating temperature, not ambient temperature, but where you're going to be operating. Understand that temperature and what you need, and use that in when selecting the monitor that you need. You know, another thing that is, you know, nowadays I think everything runs on batteries, Ed, but what type of battery options are you wanting? You know, there's pros and cons to each side. There's no right or wrong answer here, but it's what's right for your application and how you use it. You know, a lot of municipalities, this unit may stay in one truck with one operator and one group. So, you know, a rechargeable thing when they're done, boop, put it in there. But what if you're a contractor and this could go to 4 to 5 different people in different trucks? You know, maybe rechargeable is not the best way for you. Maybe you want an alkaline battery option where you can just pop new batteries in as you need it. So there's different options out there for you. Make sure you understand what would work best for you and your crew, and really the only person that's going to know that is you guys.
Yeah, so take a look. Does the monitor come home to the same place every night?
Yeah.
That would be a good point to have a cradle, set it in, or a charger that plugs in, and recharge it every night. Historically, the rechargeable batteries will get an 8 to 10 hour runtime. Ideally, the alkaline batteries, AA throwaways, those are historically used in the application where this thing doesn't come home to the same place every night, and we have to remember to charge it. If all I need to do is remove a battery pack and dump in 2 AA's that I can get at the gas station, and at the same time I'm getting my coffee in the morning, I'm a lot better off. Recharging could be 3 to 5 hours to recharge an air monitor. So again, take a look at your application, and it's going to vary from application to application. The other common question is, can I buy rechargeable and use a AA as a backup? In a lot of cases, the answer is yes. Some cases it's no, but you'll see that in the manufacturer's specification, and ask that question when you're ordering instruments. This one happens to be able to handle either or.
And the great thing about that is when you run out of batteries on a rechargeable, you got 3 to 5 hours so you can work again. But if you have that option, or you're running alkaline batteries, you can pop new batteries in right away and keep working. So just keep that in mind when you're looking at the stuff. I mean, there's a lot of different things to look for when looking at an air monitor ad. But I think looking at what we just covered will give you a good basis to pick an air monitor that will do the right job for you guys, keeping you and your team safe, which is the ultimate goal for having an air monitor in there. So these are just the basics of outline of kind of what to look for when selecting an air monitor. A lot of it really revolves around what is your application. If there's a time that you're not sure about the application, let us know. We have an email, dti@dohenycompany.com. We have experts that have been doing this for multiple years, like Ed here, that can dive in. They've seen a lot of what you've seen, and there may be a situation where they say, I don't know. And that's okay, because if we don't know, we have the contacts and the people to get to that we can figure that out. So when in doubt, let us know, let us work with you, or contact any professional you trust to come out there and make sure you get the right tool for your job. There is no cutting corners when it comes to safety, Ed.
Wait, could you touch on real quick where we can find this podcast at in the future?
Sure. You know, this podcast is on YouTube, Apple Podcasts, Google Podcasts. You can find it anywhere you want. You know, if you want to make sure you don't miss an episode and you can get all the training we're going to provide to you, just like and subscribe on wherever you get your podcast at. And stay tuned for more training coming up, and we hope you learned something today.
Thanks, folks.